Hello everyone, welcome. Then to another video here on the Hackintosh and Beyond channel. I'm going to talk to you about our SSDT single document, the one we use spread across the ACPs, right? Our boot. I'm going to show you how to gather all the hardware information into a single document as you see therein. Olarila himself, right? When you download 11 Wi-Fi Ali from Maldon, you see that it has only one document. This is very interesting because it is because of the good reading of the machine, right, from your rack. It is very interesting that you use the single document for the information so that boot can have a better reading of your machine. I also made an explanatory video. Which ones? What are the advantages of having a single document, right? For reading the hardware, it is very interesting. It's obligatory, isn't it? So it is to improve the performance of your machine and to have a similar reading close to one of an original Apple hardware, for example. So I prepared a very interesting video. This is the explainer video for you. And then, after returning from the explanatory video, I'll perform the procedure with you. So let's proceed to the explanatory video.
The main advantage of consolidating multiple SSDTs secondary system description taboos in a single document in Hackintosh is in the simplification of management and organization of the system, an ease of configuration and maintenance, reduction of files. Having a single SSDT avoids the need to manage multiple files, decreasing the chance of errors. How to forget to include a specific SSDT or load conflicting tables. Cleaner bootloader configuration tools like OpenCore or Clover require each SSDT to be listed in the config.plist. Combining into a single file simplifies this step, making configuration clearer and less error-prone. Moreover, avoiding ACPI conflicts controlled by the order of separate SSDTs can modify ACPI methods or tables improperly, causing unexpected behavior. When combined into a single file, the order of operations is easier to manage, often ensuring consistency. Conscious overrides allows you to adjust pet priorities. Example, fix USB before managing power, avoiding incompatibilities. 3. Performance and efficiency. Optimized loading. Bootloader loads a single file, reducing boot time. Although marginal, it is a valid optimization, less redundancy. Separate SSDTs can repeat definitions or scopes, while a single file centralizes the information, avoiding duplication. A unified SSDT can be tailored specifically to the user's hardware, integrating PETs for components such as CPU, GPU, USB, audio, and power into one logical flow. macOS compatibility. The structure of a well-crafted SSDT better mimics the ACPI tables of a real ME, increasing system stability. 5. Simplified debugging. Centralized analysis problems are easier to track in a single file, especially with organized comments explaining each session, updates facilitated. Modifying or removing PET becomes more straightforward without having to cross references between multiple files. As a practical example, a unified SSDT can include power corrections. Example, SSDT plug SSDT PMC device mapping. Example, USB via SSDT-UIAC specific hardware emulation. Example, temperature sensor, SATA controllers when avoiding a unified SSDT in cases where specific SSDTs are required for very distinct hardware. For example, notebooks with complex configurations, keeping them separate may be more practical. However, for most setups, consolidation is advantageous. In short, a single SSDT provides organization, control, and efficiency, making it ideal for well-planned Hackintosh setups.
That's it, guys. After a nice explanation that I left for you in this video, it's very interesting because the single document organizes all your hardware information, right? It doesn't leave much marginalized, as mentioned in the video. Not that it's wrong for you to use separate is interesting in some scenarios, others not. In the case of the PC, it is very interesting that you keep a single document, right? So we know that part. Now I'm going to start the procedure here, and come on, I'm going to teach you how to formalize a single document. Maybe this is the only video. It's open to the public, right? Teaching this type of procedure, because I've never seen anyone talking like that and teaching you there, okay? It's in the hardware part, so this placement is very interesting. We will do the following. The first step, we will create a folder here called the CPI. Oh, today I counted all the main SSDTs. I'm going to delete it here, right? I'm going to delete the entire folder. Let's formalize a new folder here. Let's appoint her to the CPI. The CPI. The CPI will open the Hackintosh here. We will come here in the utilities part and tip all this information here. We will come here and dump the CPI. Here's the folder that is already on the table, the CPI. Choose destination folder is already here forwarded. Just click here, choose destination folder, and it will formalize the ACPIs for us inside the folder. You can close the racking to then here. So after we did this part, we formalized the folder. We opened the racking too. We dumped here all SSDTs, including ODSDT, which is the most important. All right then. Now we are going to download an SSDT team. We are going to formalize our separate SSDTs. So I'm going to use a tool here from the channel called ToolsTops Tools. I'm going to open it here. It forms this little folder here. Top tools here. I have several tools that are used there, right? For whoever does the Hackintosh, then we got everything here. So option 6 is SSDT-Time is what I need. Oh, the folder. It formalizes empty after you choose an option here. I'll leave the link to this tool in the video description, okay? Including everything I'm going to use here in this video. I'll leave it in the description for you. So it's option number 6, OSSDT. The team has already downloaded it here for us. That's what we need. I just came here to hit 0 and get out of here, whatever. If I need any other tool, I'm done with it. Using top tools again here. Oh, we're going to open the SSDT team. We're going to open it here in Python. You can open it here. Command point is also no problem. I'm going to open it here in Python. Okay? Increase it a little more to make it easier. 6. And here we are going to choose the letter D, which is to get our DSTA people did the dump. Okay? For those who made Windows, it is also important to save this dump folder that is made there in Windows as well, because you end up using it a lot. This guy here has the original ODSDT from your machine. Throw him here. I'm doing it here on the rack. So why am I already at MX? Okay. So it's easier to enter here. And from now on, I pull the SSDT separate into the SSDT. Team. Oh, the first option there, ask. Second option, why didn't he pull IPDIT? Because I have the single document here. So mine is already ready. He ended up not pulling, but you may be pulling the third option. We're going to skip because it's for laptops, so we're going to continue here with SBX, right? In case if I had with the laptop doing on the laptop, I would choose the second option, the third option there, which is for laptops, okay? In the case of EC, then we go to the fourth option, USBX. I always go in build letter B, which is the build of my machine. So the key here, now I go here at 5, which is the one of the login type processor. Perfect. I'm going to 6 PMC. PMC didn't leave either because I'm already there. Now she's left. Number 6, number 7 RTC WAC is very important too. USB reset. For mapping, then we use it a lot in the single document. We will put it to bridge, doesn't need it. Now let's see Adamar. In the case of my machine, it doesn't need Adamar, okay? In your case, if you have done this procedure in Windows and have Adamar, then just see if you will need it on your machine. In mine, do not need then. I'm going to skip this part. We now have SBus letter CE here. I also need EPIDIT, which didn't come out to me here. He is saying that mine already has it, but I do need it. I don't know why you're not coming out here. But in your case, it will come out too. So here, guys, as I already have EPIDIT in the single document, it ended up not coming out, okay? Because he was already located and ended up aborting here. But I'm going to do the procedure with the one I had pulled here before. And here I have EPIDIT. I had already pulled this guy here. So now he is reading EPIDIT. So he is already informing me here that I don't need it. That it was found in the system. It's really cool, guys. So he really recognized in my system that EPIDIT already exists here and ended up not formalizing it. But I will copy it here without problem. This one was something I had already pulled before, so just to demonstrate to you here, impeded has already come, so the rest is that, okay? For those who have Adamar, put it there, take a test, see if you need Adamar. So let's get out here. We've already pulled the SSBTs that we just need to close, okay? Now let's start with the procedure here. Oh, I'm going to open my PSDT. I'm going to come here. I'm going to open another one. This is the SL master that I am handling the SSDTs. I will also include the link in the description of the video. Well known there already, this little program is very cool for us to be able to manipulate our SSDTs. I'm going to open another step tab, SL. By opening this tab here, we will formalize a new SSDT. What are you going to take here? Oh, copy this information to the definition block, then to the code opening. Here, oh, input it here with the Mandy C to paste it here where AMI is. You can put your acronym or your name. I'm going to put H in another. Does that mean I manipulated this file? I haven't passed anything here yet. I'm going to close mine. I can now close my DSDT, the one we pulled. We can now start the procedure here. Start the procedure. We open the part of our SSDT here. It's in DSDT. People are going to move here to S to stay SST. So I usually start with AEC, right? To put it here in my single document, I'm going to open it here and I'll paint it green so I don't get lost in the process. I'm going to open it. Oh, opening it here is very simple. Okay, guys? I'm going to show you in a very simplified way. So I'm going to copy the header here first, just this part. Here I already have this information from SSBT. I'm just going to copy it here. Oh, C command to copy and V command to paste to. Let's see if he's already compiled it here. Oh, it's already zeroed for me. It's kind of ready here. I might even save her. I'm going to rename it, put it here on my desk. Put it on the desktop, but I'll rename it here. SSDT, I'll put Z690, which is my board. Mom, oh, I'm going to put it in binary language and I'm going to save her here. It can be inside Tops Tools, even in the in folder. She'll be here in the briefcase. Oh, she's here. Okay. All right. So I've already moved on to this one here. Everything is fine. I can close it here now. Let's move on to the next one. The second one I put is from the plug and a plug processor. I'm going to come here. I'm going to copy her header. It's part of the scope. Then I come here. I give an enter lap below. I get this information from the scope until the last closure. I go down to the end. The spreadsheet, it's pretty extensive for each processor core and everything. Here comes the last closure. I copy. Command to B, Command to C. Oh, notice she hasn't appeared here for me yet. I'll compile it here. And to see what's happening, oh, there's already a syntax error here. Let's see, here is the end of the click here. It will point out where it is. There's an extra closure here. We remove one. Let's see if it will appear here on the side. It has already appeared for me. Compile the run is okay. It has to appear that way. 64. And we're going to work on these lines here. It will not disappear from here in your single document because it is part of it. If you take it out, it will cause problems in reading, so it is not recommended that you take it out, so you can save it. We already added the plug here. I'm going to paint it green so I don't get lost in the process. That's it. Now I'm going to put EPDIT PMC, and then I'm going to the USB part. It's here in EPDIT. The header always copies it first copied here. Let's go back in our document. Enter here. We copy the header for our single document. Come up here in the scope. First scope goes down to the last closure. Already the document ready. Let's go to the end of where we added our processor there.
Oh.
As you can see, the Polar Expedi didn't appear because there is too much closure here. It's all segments, guys. Oh, compile. We have a syntax error here. Let me just reduce it a little so that it doesn't appear so much in front here. We come here, oh, Lika. Exactly that. Take off this closure, compile it again. It will 0. There will only be a 64 here, and that's what we want to save. All the procedures you do, we will paint Edith green, just for the organization. I'm going to do the same thing to PMC now. Now notice that here in our header or ester, don't you take a look, see if there's no one like it so it doesn't repeat itself, because that also causes problems. Is it in reading? Because he's going to read this document in one go. It'll save time, and it will make a sincere reading of your hardware as if it were an authentic Apple. So it's important for you to know that, oh, here I already have the same information, so I won't put it, I won't add it. He'll hit here, he'll see that he already has that information. So if you double here, it may cause problems when reading what we are going to do here to add PMC. I just came here. The scope, the header already exists in our document, so there is no need for you to repeat it here. I just came here in the scope, copy until the closing, then the end. Let's go to the end there, navigate here in our document, and it will only grow, right? Let's jump here. Scope, PMC did not appear because there is a syntax error here. Oh, the end of a premature mistake, right? Let me click here again. Oh, remove this closure here so it can appear here for us. He showed up here. Compile it again. Zero error here. Honest will stay like this. Is it really like this?
Shall we?
Save PMC. Then we included it in our document to paint it green, to know that we have already done it. She has already manipulated it. And now we go to the USB part. Let me see here. Oh, the RTC, the AC, always leave it for last. Let's leave it on standby and proceed to USB. There's much more to look into when we dive into USB functionality and how it integrates. Oh, I start with USBX ELA. You can notice that it doesn't have any header here. So you can, from the scope, USBX goes all the way to the end here. Close copy, this guy goes to the end here on the single document line. Always paste compiles here to see if there are no errors in your document. Oh, there was a mistake here, premature. Let's see where he pointed on the scope. Take off a closure. It will appear here on the side. Oh, that BX there. Then it has to disappear. A mistake. There can't be any mistakes here. Okay, guys? It's very important. Let's save it. Saved here. Compile again. And then it's 0 here. 0. Normal. So our SPX there is here in our single document. Very good so far, you are following, right guys? Any doubts were lost in the procedure? Pause. A video comes back, right? So you don't get lost, I'll leave it too. The documentation is on Discord available there, okay? You ask me in the comments of this video, I'll make it available to you. USBX, I'm gonna paint her Virgil here just for me, don't lose me. I will also now add USB reset. I'll open it here. Oh, I don't have its header in my single document yet, so I'm going to copy it here. Go up there, go up, I'm going here, I'm going to enter. And adding, oh, I added it here. XHCI hub, R hub. So I'm going to the end. I'm going to come here in the scope until the last closure. I'm going to copy unpublished material there for you guys. This material doesn't exist. I at least have never seen anyone make this kind of video. It's teaching you how to make a unique document instead of being those more masked videos, let's say so, right? Not so explanatory in this case, but it's there for you. I already copied it here. I'll add it here. So Control V or Command V for those who have it on the Windows or Mac keyboard. Let's compile here. A Himachuro error appeared. Oh, closing from above. Just remove. She showed up here for me. Oh. Then compile again and have to reset. Always save. Oh. We are almost finished with our document here. I'm gonna close it. I'm gonna paint it green. That's it, SBOs. She's just got a little adjustment she needs to make. It is important that I tell you here, oh, the header, we will copy it normally. Oh, Roman C, give an enter here. I copied it here. We have 2 SSDTs in one. Yeah, they ended up making a document, just these 2 SSDs. So when you're going to use it separately, okay, no problem. Both OpenCore and Clover, it's going to work separately. Now, when you put this document together into one, you need to separate these 2 guys. Why? Yeah, if you put it that way here, that way, no OpenCore will work normally now for those who use Clover. Clover, it separates this situation. It makes a single reading, but only if it has not been written in a correct way, readable for him. He will not understand, and then he will badge there, it will bang, and you will not be able to climb the system. So it's important to separate. So I'm going to do it in a way that's going to work pros too. So here's nothing new. We copy the header here to our single document. Let's take it here from the IF until the last closure that surpasses here the S bus. We will also give a command C to copy and a command V to paste here O on the last line. Then notice that he hasn't enabled me here yet, right? So let's compile. Let's see. Oh, there's a premature error here on the top line. It appeared here for me already. Oh, AMCHC, it's here, and bus will also compile again. Gone here, guys. Well, where is it? Many people end up failing when they are formalizing. Why? Because like this, in OpenCore, it will work the way it works. Okay? That's a correct reading, isn't it? So you need to add some, it's a few lines of code here so he can understand. Okay? Both Clover and OpenCore too, but OpenCore, he ends up reading that way. He understands that there are two SSDTs in one, but the cool thing is that you leave the correct information there for the system. Oh, I will save it. But here we're going to do the following. Oh, I'm going to copy this guy here, the device, I'm going to copy him. I'm going to make an opening here. I'm going to paste him here. It's okay if that comes up, okay? It's normal. Just come here to separate. I'm going to come here. Oh, instead of bice, he's repeating himself. You see, guys? So yeah, you're going to write scope, and you're going to get this 0 buzz. You're going to leave it like that. Oh, and the point is also important. Now he already recognized the scope here and the band 0 underneath, which is the rest. Now is the reading correct? It's not in OpenCore the way it was. It would work, but in Clover it doesn't work anymore. You can't upload the single document because Clover ends up not understanding what was written here. So it's important to point out that we have two SSDs together here. There is OMCHCE. We also have SBus. So it is important to know so that we can separate here that for those who use Clover, right? Now for those who use OpenCore would work that way. But it's like I said, it's written correctly, not exactly, right? So it is important that you leave a correct reading. Oh, we can compile it here now. He will point it here for us. Oh, finally. Notice that he didn't point anything out, right? I told you here, oh, this way it will do a normal reading. And there is this code opening here too, which is important to have here. OU, put the opening there. Of course, we copied the one below, right? The rest. So with the opening of the code, we just put it up here and renamed it. And here, oh, when you go to compile, it gives a premature error syntax. In the end, what are we going to do here? Let's add more closures so we can see where it is, what's going on. Let's add a little more. I think it's okay. Let's compile it again. Then now he will show us the error. Sometimes there is some kind of closure missing at the end of the line. So it's important for us to know that too. So let's see where he pointed to me here. Oh, in this closure here, we need to remove him. Let's see. We need to remove another one here. You need to take one more here. It was just to add one, right? We zero here. We have a single document there, functional. Now it will work for Pros 2 boots. It's pretty cool, okay? 11 clean writing, right? Your machine will understand. Yeah. Are you going to draw that conclusion? Really testing, guys. Because then I show you here is one thing, right? After you test this unique document, you see how the machine comes back from the restart. When you restart your machine, and the result is incredible, right? It's the same reading that an authentic Apple does. So here it is. Oh, I showed you how to assemble it from scratch by taking it here when it pulls from the SSDT team, right? So it's here. Oh, let me just close it here, and now ARTC is missing, which is very important, right? Like I said, I always leave her. Finally, let's open up here. We also have her header. With the copy, shall we? Enter here, which already has a lot of space. I copied it here. I'm going to come here at Espopo Roman C. I'm going to the last polo line here. It didn't appear because there are more. Since there was nothing here, then he asked me to add a closure. But now he's like, no, he didn't point it here. For me, it is because there is one more closure. So just compile that this error will appear, but it will point up here. We remove the one we added and OK, zeroed here. That's it. Now, to make it a little better for those who want to add GPRW, people can also add GPRW by downloading it for those who need it. So you see, it's a simple procedure, okay? But you need to understand. How does language work? The CPI, right? So this is how I showed it to you. There will be no mistake, okay? You're ready, hear me. I'm going. Download now to show you here. Only me? No, thank you. Oh. I had already downloaded here. I perwoe her playlist with the information. Then you just add it to the playlist too and download it. But here I will show you. You can come here. Go down a little more here. We have, I'm going to open here the original OSSB.SBT of the machine. I'm going to close for now our single document. I'm going to give a comma DF here. I'm going to come here in mode, GPRW up to 2. I'm going to copy. I'm going to throw it up here, give an enter there. Oh. Are you saying you don't need it? Why, guys? I'm already using the single document in this case, so the reading is perfect. It's very perfect. So he already recognized that I already have it on my machine. So here he ended up not pointing the GPRW to me, but my machine needs it. Yes, it needs you too. In this case, it will need it. But when we use it separately, this ends up happening, right? From the machine. Sometimes it doesn't recognize, it doesn't make a reading, it doesn't make a nice boot. So it's important for you to know why you're using a single document, right? And a correct way of doing it. So this is an example, right? Here I need the GPRW. He just didn't point it here to me because I already dumped the machine with a single document. So it already pulled it here that I don't need because I already have it there in the single document. Oh, I'll even open my EFI here and I'll show you. I'm using Clover here, but I also use OpenCore, so it works for both situations. Oh, I'm going to open it here. I'm going to show you at the CPI. Oh, it's a unique document, and here I have, ACPRW. It's here, you see? So he already did this reading to me, that's why he's not accusing here, but I do need it. Oh, so what I'm going to do here is that for you, it will accuse normally. It will show that you need GPRW. So most hackers these days need this guy, don't they? Hardly that will happen. Only in this case has he already read the single document. So it's normal for you to see how the procedure works. Okay, guys? The business stays is another situation. Come on. I need the GPRW, okay? And here I'm going to download her pet. Oh, you come here just to download it? I already have it here too. Oh, I showed you, didn't I? GPRW also, if you were to download it here, just click here. Come here in Runal. You can download it here too. Oh, beauty. Here are the two situations we can close OTST. That's it. Now we will add it to our single document. It's here in Top Tools. I'm going to leave it here on the table so we can have easy access. I'm going to paint it green so I know we've moved it. I'm going to open it here. I'm going to add GPRW. I'm going to get the header here that I didn't have in my single document. I always leave this guy last, the RTC. So I give an enter here between the RTC, EOXHC hub. Or it could be anyone else, right? I'll put it here in the middle. I'll see it here on mouse. I'll go to the last additional closure. GPRW there. Okay, let's compile. She has already painted an error here for us prematurely up there to remove this closure. She will already point it here for me to close the GPRW. I will compile it again and reset it here for us. I can save it, and that's it. Oh, we added the GPW here, remembering that you're not on your playlist. You have to add this pet here. Oh, it's in the CPI, pet in the GPRW. In some cases, you have to take this O2 here, but it hardly gives any problem when you don't take it off too, okay? That's because this number is more here. But no, it doesn't bother you, does it? In some cases, but if you feel that the machine is having some kind of problem at sleep time or something similar, I took this 02 here, but if they haven't taken it until today, it's because it has no effect, okay? But you have to add it to your playlist. So I'm going to put it here now for anyone who wants to remove it. Let me just add it here in the OpenCore. I'll show you here. The CPI pet O I already have here, but in your case, if for example I don't have and I'm adding now, I just came here, open the downloaded pet, gives a command C, comes here on top of pet O, the CPI pet, and just paste it here. Oh, the way it is here for me in Clover. Oh, here too, I'm using a single document. It's the same with OpenCore. I'm going to close the OpenCore here. I'm going to open the DO. Clover Odo. Clover is the same situation. Have to add here also in the config playlist do. In Clover. The CPI DSDT is in Clover. It changes a little, but you come here in pets. He has to be here. Oh, mine is here too. At first it's the same thing, just paste this guy here in pets, right? ACPI pets. Close him in here, okay? You will add a GPRW and it will also work for any situation, okay? Any SSDT you are adding, this is how you put it there in the header. See if you already have it, right? In this case, if you don't have it, add and put the ACPI Pro radio codes broken down for you to have a good reading there in the case of boot. And now we're going to open our hacking here. Are you coming to the tour? In the USB part? All right. I'm going to come here. Oh, export. Then we're going to take OSDT. Oh, we have an interesting situation here. UIAC, for those who want to add, she's already taken all the mapping, right? I believe it. Here, with you who have already done the mapping, everything is fine. So USBPorts also already has the mapping of your SB map there. Yeah. It is very interesting if you want to use it without problem or continue with the same SB map. But she pulls the whole part of sleep, right? Power, sleep, awake, also port and wake power. Simple is also very interesting. And here she already has all the mapping ready, right? He pulled from the mapping that I had already done. So if you want to use it instead of the USB map, okay. So just change the playlist too, no problem. But the guy we want is this guy here. Oh, we will add it to our single document here. Let me do one for the title of organization here that we pulled from the Rakim. Let's open our single document so we can add this guy here. Oh, what you mean? Then you'll get an even better read, okay? In this unique document here, which is very interesting, few people use this mapping SSDT, and they also end up not using OSBPorts. It is interesting when you are going to use a single document that OSBPorts. It already has a little more information than the SB map itself. Here is the part that is within this SSDT here in SBPorts. It already has more information, but for those who don't want to change, everything is fine either. There is no need. Huh? It's more of a reading title. Yes, it's interesting to leave a very dynamic reading. Clara for the machine. So let's add this guy here. He doesn't need us to put the header here. Come here in device, go to the end, closing, copied. Let's go to the end of our single document, click. Here in the next line, glue compiles again. Oh, there was a premature error here. Let's click where there is only a closure. Let's see if it appears here. Oh, it has already appeared here for me. Let's compile again. It's gone here without mistake. Only 64 horns. It's spot on. And just copy here. We're closed here. It is important for USB power management. This SSDT here, okay? It is very important in this case for those who want to use USB ports that are already there. She took the mapping of what I had already done from SB map, just swap one for the other. It's important. If you're going to use this SSDT here, UIAC, it is important that you use USBPorts because it already has all the mapping here that pulled from your SB map. So it is already the way you did, but with this information here that I told you, OSB sleep ports USB. Sleep power OSB wake port current limit EOSB wake power sample. And here is all the mapping already done that pulled there from our USB map. So just swap one for the other. You can't both be in the same space because you can generate a conflict there. So it's important, 255 internal door, so it's important for anyone who's going to use it that way. For those who do not use it, there is no problem. You can continue with mapping, not with USB map either. Proof, here she is ready for both Pro OpenCore and Pro Clover, so here is nothing new for us. I'm going to do the following. I'm going to put this one we just made on my Clover Wi-Fi. I'm going to restart and come back with you the way the machine came back here for me, right? And then we will see the final result here. I'll just add her to my Clover Wi-Fi. It could be OpenCore. For those who use OpenCore, it will serve pros too. I'm going to remove the one I made here. I'm going to delete it here, and I'm going to put the one we made now. I'm just going to check it here at the club. We don't need to give a clear snapshot, but in the case of OpenCore, you have to. Give it what you want, snapshot, because you are adding 11 new CPIs, right? A new SSDTE. This is a more complex document, let's just say, that it will make a single reading, right? So it's important for you to know that too. Here at the club, he has AutoMed, so there's no need. I'm gonna reboot. I'm gonna close here. I'm going to open the OpenColor one too. I have the same documentation here. I'm going to make one. I'm going to put it here in Top Tools just so I know how to rent it here. The color pen too. I'm going to restart this guy here on the playlist. We need to give the playlist because, you come here, ACPI added. I only had it here, SSDT single PC 0. So I'm going to come here and failing OK snapshot. Save, then just organize it here. Olavo Schuler, I'm coming here to the CPI again. Then you have to be here. Oh, SSDTs 690 beauty here, added to the club and OpenCore. Then I'll reboot, guys. I'll be right back. Well, that's it, guys. After having restarted the machine, I put the two SSDT. Unique is Z690, which we renamed in both OpenCore and Clover. Okay? I didn't even tell you. Each boot has its particularity. So OpenCore was okay. Clover had some problems. I'll show you, right? It was occasional. I made this situation to show you that in Clover, he is a little different. Maybe Clover, it already has more established control of SBUS than in the case of OpenCore. That's why OpenCore accepts it that way. Then I'm going to show you here. I recorded it live on my cell phone, right? Then I'll go. Passing here via AirDrop to show you the situation, how it turned out. Share here via AirDrop the videos, show you how that and behaved with single document. First, I'll show it in OpenCore, then I'll show it in Clover. Like I said, every boot has its own particularity, right? So I believe that in the club, the SBUS control is a little more stable. So that's why he doesn't need it. It is not a requirement for the boot sent here. Deleting this one must have spread at the time of, let me see this one. I'll open up here first. I got into the Ventura part there. This one here. I already had a single document, so I'll show you. I recorded it from my cell phone here. It went up normally. I went in and I was able to get into the system, right? Show it to you there. This is the Ventura that I have here. That's it. Here's the HD. I entered through OpenCore with a single document. I'll show you the document is there. OSSDTs 690 made a great read on OpenCore. This is OpenCore. Oh, that's the document. Is that correct? The way we did the procedure here. Okay, so the same document that we created here, we created together here, right? SBUS control is probably Clover already has SBUS registration, so he didn't accept it. He accepted OMCHC, but OOSBUS I had to take out. I'll show you here. This one here wasn't the E, it was what I put in, but I had to take it out later. Oh, here was the club. Let me see if it's this one here. So what do I advise you guys to test, right? Always test on the USB drive. It won't do what I did here, okay? because here I have control of the situation, but you have to do it on the USB drive for you, right? Don't have any problems later, okay? They always pass the tests on the flash drive and then move on to the main one. You may have a problem and there is no way to recover, please. So here was the first situation. I tested the OpenCore, then I went to test the cover, and it didn't go up. It didn't go up, okay? It stayed in this situation. Even at -B, he gives this information here to us. Oh, let's increase this information that he gives here. It's a case that happens to you. Oh. For several times I tried to go up and it didn't work, right? Because of the SBUS that was really causing trouble, right? Like I said, each boot has its own peculiarities, so it's good for us to test. Then after I removed the SBUS, I left only the OAD. Then he climbed the Clover normally. I managed to get into the system. I'm going to open my FI here, and I'm going to show it to OPA. Get out here. Here he got it. Clover went up. But I had to open Clover's AFI here. For you here is the one that went up now, but I had these problems. What happens is, it's what I said, Clover. It creates a record, but I believe that Clover's SBUS control is already well established, so I left only OMCHC. In this case, then you will test, guys. It is as you test on the USB drive that I did not say, but you will test and you will put here the SBUS until it can have a control. For me, it happened this way because I already had 11 single documents here, which is this one. He already has SBUS here. He already has. Oh, there's the scope here. It's the way I showed you. Then this one is going up normally. But this one I did is the new one, a procedure with you. He had this problem on the US bus. I had to take him out so he could go up here like this. What did you see, right? Then he came up here. Oh, let me see that it's Clover here. Right? After I took the SBUS here, okay? But then you test it to see if he will accept it. In my case, here is already the SBUS record, which is why this problem occurred. But if you do this code drawing here, to add SBUS there for those who are using Clover. For those who are using OpenCore normal, right? You saw that it went up in the first place with the first documentation we made in this. There is no problem in OpenCore, right? Now in Clover, I already had this problem. Oh, the first climb here in OpenCore goes right away. It has already climbed there to our rack. So I chose Ventura here. That one has already climbed the machine normally. So for those who haven't watched the entire video, it's good to watch the entire videos So there's no surprise there, right? So don't drown, do it. Watch the full video. So you can do the procedure later, okay guys? Otherwise it will complicate later. And so always test on the USB drive. Don't forget that, right? No, they won't touch the EFI that's working there for you without going to a pen drive. Then you pass a single document that works perfectly. Oh no, OpenCore, it went up first. Because the control of SBus, OpenCore boot, it already needs SSBTs to have greater control. Clover, on the other hand, is more stable in case of any problems. Can you make this code drawing that we made here? Oh, if there's a problem, you don't have to take the header off, okay? If you have this problem, come here on SBus. They just take it from Scoopa here until closing. Just take the SBus here. Beauty, oh, if you're gonna take it here, oh, come on, Pilar, nothing will happen. Oh, the writing is correct here, so just save it. Just save it again and see if it goes up on your machine. So always test with less V so you can see what's going on. So when there is this type of bug here in no minus V in debugging mode, it's because there is some writing that he can't read. In the case of Clover, there is OpenCore, guys. Did you see that the way we did here, he went up? Calmly, oh, I'm even going to show it. I'm going to close the club here and I'm going to open EFI from the OpenColor ACPI. Oh, it's here. Oh, ZT500 SSDTs S690. Oh, it's here with SBus control. It's with MCHC. It comes from the IF and up to here the SBus. So the OpenCore there working normally is, I believe that the SBus control, which I didn't tell you in Clover, is more stable. So he doesn't have that much need. But yes, as I tested it here, for me it's stabilized in the one here that I had already done. I managed to put it in this drawing, but then you'll test it, okay? Leave me alone so far, oh Usit Mechi. Then you remove the buses and go up the system. Then you come back with the buses to see if not. It's not a problem. If he goes up normally, okay, otherwise. Keep it configured as I've shown here. I'll reopen the OpenCore. This is from the club. If it doesn't initialize for you, just leave it as is. You can see I'm without SBAs here. It's intentional. But then, as I go up here, I put the machine in and I test it. Then in case he comes up, okay? If you can't leave it the way it is here, it won't interfere in any way with the operation of the machine. In the case of Clover, which already has greater control, there are machines that will need, there are machines that will not. In the case of Clover, OpenCore, I'm not even telling you, no problem. Do you understand? Guys, I understand. So far, everything is clear. You can leave questions, comments, right? It's any kind of doubt. Then you can leave it in the comments of the video or in our disagreement there in the general tab. Look, I have a question in this video. You can put your doubts there. We will try to resolve them. So that's what I wanted to show you. It's a very interesting material. This here is for those who really want to take a turn there in the hacking part of Tosh configuration. This part of ACPI is very important, isn't it? Which is basically the heart of our rack. So it's very important. Okay, guys, that's what I wanted to show you. Subscribe to the channel, share information with friends. It is always good for us to share knowledge. Let's spread knowledge there. And the guys also met our channel here. The content of the channel is okay, guys. Stay with God and peace.